Hello everyone, welcome to lecture number 7 on IoT. Um, if you have gone through the last lecture, we stopped at this particular portion where we first looked at the components, especially the sensors and the actuators which makes up a IoT device. While we went through our examples, right, and we ended up over here. Before starting, right, before continuing from this point onwards, we will first look at a small review of what we have gone through and what we are trying to understand till now. So we went through IoT, right? We took an introduction to IoT, right? Then we went through IoT examples to understand what are IoT, right? We will first look at the introduction to IoT. I will read it through just to refresh. Internet of Things describes the network of physical objects or things that are embedded sensors, actuators, processing ability, software and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So this is a basic description of IoT. There is another while I was going through some content, I actually came across another interesting definition of IoT, right? And in that, the basic understanding of IoT, how that person described was IoT, making IoT device is the attempt to make any physical object into a computer is IoT. In the sense, in 2023, where we are right now, with the technology we have and the capabilities we have, because IoT now have the ability to use cloud computing, AI, and big data, those topics in together be a part of IoT as well. So in that sense, making any physical object or physical thing into a computer would make sense as IoT. What we are trying to do in IoT, basically we are trying to give the internet, the internet connecting to we are trying to connect all physical objects as much as possible to the internet and try to give them processing power as well, with sensors, with input and output, which means it's basically getting a physical object and making into a computer. So continuing with our small briefing on what we have already learned, we went through examples, then we went through our applications of IoT devices, then we looked at an introduction to the architecture of IoT, right? We talked about devices and sensors, networking, cloud platform, application layer, so on and so forth. Then we took an introduction to the basic components, and in these components we talk about when making an embedded IoT device or making IoT device, what are the components which is being used, and we talked about sensors, actuated embedded systems and network devices. Then after that, in the next set of lectures, we try to understand these components, what are these components and what these components are there for, right? We talked about sensors from temperature, humidity, pressure, motion, proximity, then sound, gas sensors, accelerometers, gyroscopes, so on and so on. Then we went to actuators. So basically, if you are talking about sensors, one of a easy way to describe them is anything that tries to detect the surrounding nature, properties of the surrounding nature, things like that could be categorized as sensors, right? Additionally, accelerometers and things like that would say, and gyroscopes would actually figure out the orientation of the physical object itself, whether it's moving or whether it's moving, spinning, or things like that, right? So basically, sensors are there to take the understanding of the natural environment surrounding and the device itself. Then we went to actuators. Actuators are mostly there to give an output, as well as inputs as well. In some instances, mostly it's there for outputs, taking in the readings from the sensors, and after processing in the embedded system, output commands can be given to each actuators. And we talked about how sensors and actuators, even in the same category, if you take motors, if you take gyroscopes, there are different products from different companies with different specifications. And we talked about, depending on our requirement on our IoT project, we have to select them. So bit of a research have to be done before creating your prototype from by combining sensors, actuators, and embedded systems. So other actuators includes, most famous actuators includes servos, LEDs, speakers and displays. Then we have other set of actuators like pumps and locks and so on and so forth. Then we talked about networks, and on networks there are different layers. We talked about that part as well, right? We talked about networking between IoT to IoT devices, and networking protocols such as Zigbee, Z-Wave, Sigma-Vox, LoRaWAN, things like that. Protocols like that are there in the physical layer. Physical layer means also that means connectivity between IoT device to IoT device. So still we haven't discussed about deeply about these things and why they are there, but that is those are protocols dedicated to IoT. So we talked about each and every network protocols and network systems which are there for IoT specifically. Then we talked about embedded systems, and we talked about the main two embedded systems, Arduino and Raspberry Pi, which is mostly used for prototyping, right? And we got some examples as well. Then after understanding the basic components, right, we looked at the architecture, right? We from the architecture over here, we have the physical device. We looked at the components, we try to understand the components. After understanding the components, we then looked at what are the components there in each and every device. We took as examples in our first few lectures, right? We went through them one by one, and after few examples, after this example I talked about, so at what point or which point we are talking about, and what the differences between IoT system, IoT device, and at what is our end goal. Our end goal is to build a IoT device, or to build a IoT project which would resemble a device. So in that perspective, right, we understood that sensors and actuators connected to a processing system, or in this case an embedded system, right, working together. So the process in the embedded system would process the data, the raw data which is given through the sensors, and if needed, if there are actuators, the processing system will then give out commands to the actuators to carry out work, and so on and so forth. So that would be along with the networking ability, that would be the IoT device, or the IoT embedded device, a single IoT embedded device. This single IoT embedded device has the ability to process data, does not need the does not have the need always to connect to other devices or the cloud to carry out some of its functions. Not all of its functions, but some of its functions. In a network of devices working, which would be connected to the cloud as well, or data centers, we call it edge computing, where the computer itself would do a part of the processing. That example, that this processing power, or this example, a thing that I can say for making it more sense, a real world application would be, if you take gaming, online gaming, right? We have gaming, we have phone games like PUBG, we have Call of Duty, right? We have Dota, we have gaming like that. But in gaming, right, there is a significant amount of processing happening inside the computer itself before sending the relevant data into the internet, right? You will receive and send data, and that data will be processed into the graphics you see on your screen. So most of the graphics you see on your screen, most of the information that you see on your screen while playing the game, the movement itself that you are doing inside the game would be processed in the computer or the smartphone you're using to play your online game. The data of what the other players are doing will come to you through the internet itself. So similar scenario takes place in these IoT systems, right? So the basic component of an IoT system would be the IoT device, or the IoT embedded device, and that device has its own processing ability of the data which is being collected through sensors and actuators, through sensors, and would have the ability to not only process data which is given from sensors, would have the ability to process and give instructions or give commands to actuators to carry out a output function, a physical or a visual or sound function. So as you can see, these examples, when we talked about it, the camera, the smart thermostats, or the control smart lights, smart smoke detectors, to control units, to robotic arms, to smart fridge, to Roomba vacuums, are all IoT devices. That is what we are trying to understand from here. These IoT devices have the ability to connect to other IoT devices and work together in a IoT system. Example of this, if you take a surveillance system, there would be dozens of motion sensors, dozens of cameras, which will be interconnected between each other and surveilling an area. It would be connected to smart lights, smart IR lights when it is to see when it is dark. So things like that will be there as well, right? So that would be a example. So so different IoT devices, it could be this, and even doors and windows would have contact sensors. All these will be connected to each other, talking to each other through the network they have, the IoT network they have, and carrying out a surveillance function. That is so let's say a whole building is covered by this system, or a whole area is covered by this system, right? And when these IoT devices need to relay that information to anybody or any party who is authorized to view that information, they can talk to the internet. Through cloud and cloud processing, they can talk to other IoT systems and other give outputs to other, either it could these IoT systems could be a control center or your smart device, or so on and so forth. So inside these IoT systems there will be other IoT devices that would give outputs in visual sense if it is a surveillance system, or any other depending on the IoT function, right? These networks have not only the ability to connect to IoT systems through the cloud itself. When connected to the network, IoT system to IoT system communication is also possible. So these were the points that we were talking about, and we talked about so when coming into the four main components of IoT, we talked about network devices. And when we talked about network devices, right, so when we talked about network devices, we talked about networking in the physical layer. We talked about what are the IoT dedicated networking protocols like Zigbee and Z-Wave, LoRaWAN, NB-IoT, and Sigfox. These protocols are normally used in this networking, the networking over here inside the IoT system. From this point onwards, this could be a router, right? This could be a AP, right? This would be the access point to the system, right? From that point onwards, the data will be traveling under internet or normal networking protocols. But inside the IoT system, we can use dedicated IoT dedicated protocols as well, right? So this is the point we are in right now, right? So our end goal is to go to a point where we can create a IoT device. So one of the points that you must be thinking right now, these IoT devices, right, doesn't look like they have sensors, or they are refined products, right, compared to a project. For example, if you look at this picture over here, right, this is a IoT project, or this is a prototype, right? This is messy. This doesn't look aesthetically pleasing to the eye, but this is a IoT device itself. It has functions. It will do. So when you create a IoT prototype, it will look something like this, right? it will look something like this. Then after that, when you show that your prototype is functional, then the next step would be to design a beautiful cover for mass production, where you will have the whole entire unit made out, right? That could be done by 3D printing. I'm not sure that whether 3D printing is there. If not, it would be you can talk to mechanical engineering students or mechatronics. That is something they also that is something they learn about the part of 3D printing. What we are mainly concentrating on is what is inside these devices. Inside these devices, we have the sensors, the processing power, and actuators, networks, so on and so forth. So before going into the next, so we can go on to the next set of examples. But before going there, I will refresh your minds of one more point, which is that when we talked about these examples above, right? When we talked about these the above examples, there was a shared set of every IoT device shared a property or shared a set of devices on top of these sensors and actuators. One is the processing ability, the embedded system or the processing ability. Second is the networking ability. Third is the power source. Each and every IoT device has the processing ability, has the networking ability, and has a power source, right? The things mainly change are the sensors and the actuators. So I would like to highlight that point again, right? Before talking about the sensors and actuators of the examples we talked about, each and every one of these IoT devices that we talked about and the IoT devices that we are going to talk about, and any IoT device would commonly have the processing ability, right? That means there will be a processor, embedded system, the chips needed for processing, the chips needed for memory. There will be networking, the ability, the networking ability would be through cabling methods or wireless, with wires or wireless, depending on each product. Some kind of networking ability would be there, and the power source, either through stored power like batteries and recharging the battery, or directly connected to the power grid, right? Depending on the situation, depending on the product, but there will be a power source, right? So with these three properties, each and every product would have a set of sensors and actuators. Now we can talk about rest of there are another 6 examples we talked about. We can talk about all these 6 examples and what are the sensors and actuators they use. Smart locks. So in smart locks, we have the picture we have right over here. You can see that there is a fingerprint reader and a keypad to type in a password. Normally smart locks or any lock would have two-factor authentication to increase the security and to have a secondary option if one of the authenticating options would not work, right? So here it is the fingerprint reader and the keypad. You may have seen that RFID cards or NFC cards can be cards or authenticating tags with RFID connections. Even the RF signals of your phone or the NFC signal of your phone can be used for authenticating locks for accessing areas and security purposes. In extreme cases, we have seen, we can see this normally in movies, but this is something there, iris scanners. So iris scanners are there as well. So there are different types of authenticating methods in different scenarios for access control. All of them comes under, all the locks comes under the category of smart locks. And yes, they are IoT devices because the registration, to carry out the registration, to carry out who has accessed the place at what time. Sometimes these authentication smart locks are mostly used to keep in track of attendance as well. If you take office complexes, you can see we can use the smart key card to see when the people who are working in that office premises entered the office, and so that would be marked as the time for time of attendance, and when leaving we can take the last time the key card was swiped in. So things like that. So in this particular smart lock which is on the picture, what are the sensors that can be seen? Number one would be an image sensor. The image sensor here will be not there for face recognition, but that could be also an option for smart locks. Here the image sensor is there for fingerprint recognition, to take the picture of the fingerprint. In your smartphones, there is another option. Capacitance are used to read the fingerprint. That option, that is more accurate when reading, so that option can also be used in the fingerprint reader. So additionally to that, we have a magnetometer, right, which would indicate whether the door is correctly closed or not, right? We talked about a contact sensor before, right? In the contact sensor we use magnetometers, one on the door and one on the wall, or we can say the frame of the door, to see if the door is closed correctly. So that option is there. Then we can go to so not only that, image sensors, there can be other types. For example, iris scanning, there will be high quality image sensors. For face recognition, there will be high quality image sensors. There will be RFID scanners or RFID readers if you are using key cards, right? So to function all this, there should be relays from actuator side. And to see if the authentication is done correctly or not, sometimes we have a small light bulb coming up with red or green, just to say that the authentication was done correctly, right? And for that we can use light bulbs, or we can have a small sound indicating that the authentication was correctly done or not. So then speakers would come as actuators. Then of course the lock should be opened. Here when I put our example when we were talking about actuators, the smart lock, right? As in the picture itself, it could unlock depending on the authentication situation. If you have seen glass doors. Glass doors goes with magnetometers. Uh, the glass doors normally use magnets to lock in the door, rather than using this mechanism, because there's no room in glass doors. So they use magnets on top, normally on the top of the door itself. These are much more stronger magnets than magnetometers, where the door is shut closed very tightly, and when only and there will be separate electricity or separate power given to those magnets, right? And those the magnetism will be controlled through the flow of electricity, either denying it or flowing through, right? So when the access is correctly given, those magnets can release the lock, so the glass door can open. So for glass doors, those options are there. Otherwise, for conventional doors, we can use this option. So if you talk about the smart locks, right, these are the set of actuators and sensors that can be used, either one or a combination of these together, to control access. For registering access, for indicating people that this person has arrived on the room, for other IoT devices to come into action, either smart plugs, smart lights, air conditioning of the room to switch on, things like that to happen, this could be networked with those IoT devices, right? Then from smart locks, we have the smart hospital bed. So here I have in a smart hospital bed, the amount of sensors and the amount of equipment which is being used, depending on the situation of the patient, is immense, right? We would have pressure sensors, not only to check the pressure of the patient itself. There will be other kinds of tubes, either giving blood, giving saline, and so on and so forth, maybe giving oxygen, and they need to check the pressure of those liquids and gases. So pressure sensors can be used in that sense. Humidity and temperature sensors, of course, for temperature sensors can be used to see if the patient is recovering from a fever or not, and things like that, right? Proximity sensors can be used whether the patient is in distress, to see if the patient is in distress or lying comfortably, and so on and so forth. Addition to this, there will be sensors to detect the heartbeat. There will be sensors to administer certain types of either medication, right? There will be pumps, valves working in conjunction to give either oxygen or needed supply of blood or things like that to the patient. There will be motors in the bed to control the bed, the height of the bed, the adjustment of the bed from every angle. There will be other monitoring tools, various kinds of monitoring tools depending on the sickness, right, which would have different kinds of sensors as well as actuators to facilitate in helping the patient. So inside a hospital, if we are to bring IoT to a hospital room, there are many instances, and all of these can be networked so that the nurses and the doctors who are attending to that patient can check, keep an eye on that patient all the time, and maybe sometimes there are tests like uh, monitoring your heartbeat, monitoring your pressure, which is carried out maybe for 24 hours or more than that, and it should be done real time continuously, right? And those things can be done by IoT devices. Moving on from that point, it would be virtual reality gaming, or we can say gaming in a broader sense, right? So but let's if you but virtual reality gaming would be the most typical example, because there will be more sensors and actuators used in that scenario, right? So if you take the controllers in this man's hand, right, those controllers will have accelerometers, magnetometers, gyroscopes, so on and so forth, to understand the movement of the hands, which will be then translated into the actions in the virtual reality space. There will be sound sensors. In this case, sound sensors would be mics for communication, for giving out commands. There will be speakers in the headset. There will be screens on the virtual reality goggles. There will be motors in the on the controllers themselves to give more realistic feeling, right, through vibrations and movement. So things like that would be there. Mainly the sensors would be there again to understand the movement of the human being in real life and translate that information to the virtual reality world. So for that, we have to use different kinds of sensors to understand the positioning of these controllers in the environment, right? In that particular instance, sensors for understanding that the positioning of the controllers would come into play. Similarly, we talked about this in the robotic arm as well, to understand the movement, to understand the positioning, right, of the controllers in the 3D space, and that data would be transmitted to the computer, which would be supporting this virtual reality game, and that computer would be doing the necessary processors to take that raw data from, let's say, a gyroscope and make that data a part of the virtual reality. So from and that part would be the taking in gyroscope data and making a graphic out of it and showing it to the human through the virtual reality headset, right, would be a part of edge computing. That part of processing would be done in the IoT device itself. You can see here that this, if you take this as an IoT system, the whole gaming platform as an IoT system, right, you will see that this controller and this controller are two IoT devices. So we have two IoT devices networked together. Those IoT devices are also, then there's the sound, then there's the virtual headset, then you have your processing power. So all these IoT devices are connected together and they will be processing data. and showing and that data will be shown in graphical form to the for the user. And when the user is playing this game with other players in the virtual reality world, then that particular IoT system would have to communicate with rest of the IoT systems or rest of the players around the globe, and they will be exchanging data, right? So not all the data which would be processed in the computer would be sent, only the necessary data such as the positioning, maybe in the virtual world, the positioning of the users, maybe the health of the users, the equipment that the users use, so on and so forth, depending on the game. So from that we can go to again health monitoring devices. We talked about our hospital beds, right? In our hospital beds we talked about pressure sensors, temperature sensors, sensors that are there to monitor your heartbeat, so on and so forth. If you have seen a smartwatch, if you turn it around opposite to the screen, you will see that behind it there will be a set of sensors which are there to monitor your pressure, your heartbeat, so on and so forth. Additionally to that, your health monitoring devices would have motion sensors and gyroscopes. Mainly those things are there in your smartwatch. So basically that would be the device, the IoT device that humans will be using to for maintaining or monitor health in a non-medical environment, right? Either when you are going to the gym or when you are going for a walk or a run, you will calculate the amount of steps you have taken, your heartbeat, your pressure, so on and so forth. You will use a smartwatch, and that smartwatch will be relaying that data to the cloud for storage and so on and so forth. It will be synced with your phone. It would have your emergency contacts information if something would go wrong even. So again, to monitor your blood pressure, heartbeat, there will be pressure sensors and other sensors to do so. Of course, they have motion sensors and gyroscopes to calculate the amount of steps you take, so on and so forth, and it will be communicating with your phone, from your phone to the internet, to take in data of taking GPS data to see how far you have traveled and so on and so forth. So that would be from your smartwatch. And of course, as actuators, there will be a screen, a touch sensitive screen with capacitance to interact with the device. On top of this, there are health monitoring devices. For example, you may have heard of pacemakers. So this is a common device which will be implanted for to measure the heartbeat of a human being, right? Those are very important devices. And those devices have the ability to communicate with networks. The modern ones have the ability to communicate with networks. Some of them are old legacy systems. The legacy systems would not be able to communicate wirelessly, and they would need to be going under a small surgery to take out the data. But newer systems have the ability to connect wirelessly and give data even in real time for the doctor or any needed parties and the user. On top of that, there are many IoT devices that uses sensors. You may have seen people without arms and legs are getting artificial legs or artificial hands, which can actually work by connecting with sensors to your neural neurons in your body. So even today, these are very expensive systems. These are new systems, but they are there. Then there are other types of health monitoring devices depending on different sicknesses or different situations that humans have to face. So, for example, one of the best examples would be if you are a mountain climber, or if you are going to if you are going to a place where there is a lot of pollution. The best solution would be to carry a oxygen meter to check the amount of oxygen in your blood, so that you will be safe. So to do that, there are other small devices, and those devices have the property of IoTs because they have the ability to process. There will be sensors to actually measure the to actually measure the amount of oxygen in the blood and process that raw data and give it in a informative manner to the users. So health monitoring devices does not get limited to smartwatches. There are many examples, but here the example we used is a smartwatch. And of course we know that there is three main features which is common for all of these IoT devices: networking power and processing power. We know that smartwatches have them in the form of a battery. There is enough processing power in the smartphone. We know that because there's a touch sensitive screen and enough graphics going on in the smartwatch, there is a GPU as well. We know that it can be networked through Bluetooth for any mobile device. So we know that those features are there. On top of that, we know that we can look at the heart rate, pressure, and monitor how many steps we took, and so on and so forth. To obtain those information, we have the rest of the sensors. And if you are talking about, so sometimes when alerts comes in, or if the watch needs to give you an alert, if you are on a health kick and you want to get some steps in, right, a reminder can be set up. For those, there will be a small motor inside the watch just to give a small vibration as a reminder. So things like that would be also there. Those actuators are also there on the on your smartwatch. So in general, smart or health monitoring devices are an important part of IoT, and by looking at the need of the user, right, what they have to measure and what they have to keep in track, either the blood oxygen levels or the platelet count, or it could be much more sensitive things, heart rate, pressure, even the amount of or the amount of urine or the chemicals inside urine. So things like that we used by scanning them, by using sensors to check those properties, we can determine whether the person is healthy or not. So these health monitoring devices beyond the they are sometimes used beyond the hospital by humans to keep a healthy life. And the next topic is autonomous driving vehicles. This is one of the extreme examples of IoT, and we can say that each device is a vehicle. We can take one vehicle as a device. And before going to the external connectivity between device to device, that means vehicle to vehicle, right, we can first look at what are the sensors that are there in autonomous driving vehicles. Not only these self-driving vehicles, we can also look at examples of conventional vehicles, because today the conventional vehicle have more sensors, processing ability, and actuators built into it than the past. So if you take if you take Mercedes or BMW, and if you take Volkswagen, they are electric versions of cars, and they are combustion motor vehicles. Both have numerous amounts of sensors, multiple number of devices working together, sensors, actuators, and everything working together inside the vehicle to function. So if you take a self-driving vehicle, one of the main things that is needed to be measured is the speed of the vehicle. We will have accelerometers there and other devices to measure the speed of the vehicle. And one of the most important things is cameras. In Tesla vehicles, they use their the primary way of understanding its surroundings for the vehicle to move forward is cameras. There are other companies which use systems like LiDAR systems to understand the surroundings. The thinking behind Tesla to use cameras is that humans can use visual signals to drive along a road, can read the signs of the road, the red lights, and of course the lines in the road. So by using advanced image processing and AI technology, that these decisions can be taken by using image sensors, right? So that means cameras. LiDARs, on the other hand, have the ability to navigate through off-road situations, because they can create a 3D map of the surroundings using their radar to understand what are objects that can go through and what are objects that cannot go through. So Tesla vehicles will not perform in remote locations or where there are broken down roads or virtually no existence of a road. But LiDARs have the ability to go off-road. So that is one of the things. But maybe if image processing and the processing power increases, Tesla vehicles would have the ability to go off-road as well using image processing, because the processing power should be more to understand the surroundings, but end of the day, that if the processing power is there on the vehicle itself, it can and navigate through the terrain. So that is something extra. So then we can then of course proximity sensors. Even in vehicles which are not totally self-driven, proximity sensors are there, right? When you are reversing a vehicle, you will hear the sound when you are getting close to, or have a warning light when you are getting close to some object, right? And you will get warnings when you are traveling fast, and when you get closer to an object without braking, you will get warning sounds, lights, or alerts, things like that. So that means proximity sensors are all around. So self-driving cars should have the ability to understand what's next to it, what's close by, either if it is if some object is nearby, so that it cannot drive that way, so it have to change direction, so apply brakes, so on and so forth. So proximity sensors are important. Motion sensors are also important in that way, because there will be a lot of things that will be moving around the vehicle as it goes along the road, because it's not only one vehicle which is going down the road, there will be several other vehicles. So to understand what's happening around the autonomous vehicle, we can use proximity sensors, motion sensors, image sensors, lidars, a combination of all these to understand what is happening around the vehicle, so that the vehicle can drive. So additionally to that, there are touch sensitive capacitor buttons to control, and of course the steering wheel is touch sensitive in autonomous vehicles to see if a human being is actually driving or have control of the vehicle. These are something regulatory purposes it should be there. And we have I have also added a humidity and temperature sensor, and that is to mainly climate control. So inside vehicles nowadays, climate control systems are there to similar to what we were talking about in thermostats, right? So a thermostat system, a temperature monitoring and control system, or a thermostat system would be there in vehicles. In that, the word temperature so in vehicles, to regulate the AC, or to regulate the heating system, to regulate the heating of the seats itself, a climate control system, the word is the climate control system, will be used. So heating is something that is off topic for Sri Lankans, because we don't use that at all. But in countries where there is a winter, like air conditioning, heating is necessary. So there should be temperature sensors to understand the temperature outside of the vehicle and inside of the vehicle, to keep the temperature at a constant when you are on when you set up your system to automatic. Pressure sensors are things that you can use in combustion vehicles to measure the pressure of oil gauges and so on and so forth, as well as your tire pressure. On top of this, if you are driving an electric vehicle, that means there will be batteries, that there will be a big, not a small motor like this in the picture, but there will be a bigger, much more powerful motor. There will be number of relays will be there to coordinate the electricity inside the vehicle. There will be servo motors, maybe to press on the acceleration, or to turn the wheel, or to turn the driving wheel, or to turn on, like to fold your side mirrors, your windows, so on and so forth. Servo motors and things like that can be used. So as we can see here, a autonomous driving vehicle or a semi-autonomous driving vehicle uses a number of actuators plus sensors to carry out its functions. The amount of sensors that is being used are endless, from automatically opening doors to right, so to if you have a the 360-degree reversing cameras to understand the surroundings, so on and so forth. So a vehicle, if you take a vehicle as a IoT device itself, it is one of the most ultimate IoT devices that we can find, because the use of sensors, the use of actuators is a vast quantity being one device for different purposes, right? So we know that Tesla is the one that mainly pushed this, but automatically reversing into locations were there before Tesla came along. Then after that, today that we find BMW, Mercedes, Volkswagen, and even we have American companies joining in. If you take the Hummer, it's a fully electric system. You have Rivian, which is a new electric company, which is also gunning for automation. We know that in United States there are automatically driven cars in some areas. Still it is restricted to either a small town or a small city or places like that, but these things are there. There are autonomous delivery systems to deliver your let's say like your Uber Eats, some things like that. In United States, we have seen them succeeding as well as failing to navigate, but we are still on the starting edge of these technologies, autonomous driving vehicles or autonomous driving units, depending on how you look at it, but it is a major point of IoT. So that means these vehicles have an immense amount of processing power inside them. That is also something that is needed to be considered. We know that each vehicle has a method of obtaining power, either through combustion engines or using batteries, so that directly electricity will be stored. And we know that these vehicles have the capability to connect to the internet. That will be normally done through a cellular connection, right? Through a cellular connection. So the very first connection or the very first example would be the GPS navigation system inside vehicles. On top of that, nowadays you can take facilities such as Netflix and other streaming facilities like YouTube on your vehicle, and on top of that, autonomous vehicles like Tesla use the data which is being collected by somebody who drives the car. They will use that data to refine the driving experience. That means if you have a road that is hard to navigate, right, every time a Tesla vehicle navigates that road, either manually or autonomously, that data will be collected into their central database or into their cloud. So each car would be sharing its data from to the Tesla cloud, and in that large set of data will be processed, and the optimum method of driving through that hard road would be will be calculated. That optimum method of driving then would be updated into each and every Tesla car, right? So when next time somebody is driving through that road, that data will be available in the car, so the car would take the best optimum driving path on that road. So things like that are also there. We know that if it is a full electric car, just by a simple software update, we can increase the range, we can increase the battery life, so on and so forth. So these are also bordering between IoT and other technologies. So one of the things that we have to understand going into the future is that the line between either AI, cloud computing, IoT would be blurred. There will be no much difference between these things. So that is also something extra that you should understand, because when you are using when you are developing IoT system, cloud computing, AI would come into play for making decisions from the data which is being collected, so on and so forth. Okay, so from autonomous driving vehicles we can go for weather monitoring devices. So weather monitoring devices, we have pressure sensors, humidity and temperature sensors, light sensors, moisture sensors, wind speed sensors would be there, so on and so forth. We have there will be a lot of sensors either directly informing the nature of the environment, the situation of the environment, or there will be sensors that would be working or giving data in a third party sense to understand the environment, right? Before going into third party sense, let's look at the direct use of sensors. For humidity, temperature sensors, it is obvious. Pressure sensors, again, it's the atmospheric pressure, we can check on that. Light sensors, to understand the lighting condition, the amount of sunlight we receive. Then we have moisture sensors to understand whether it's raining or not. We can use so for example, we can use instruments like this for the wind, to calculate the speed of the wind. The wheel would spin, so a third party sensor would calculate the speed of the rotation. That data, the rotational speed, would be then calculated through a formula to give the accurate wind speed. If you have a camera sensor, you will be able to understand whether it's if lightning is taking place or raining is taking place through image processing. That's a not a direct approach, but a approach nevertheless. If you have a sound sensor for these weather monitoring devices, it could monitor the sound of the thunder, it could monitor the sound of the rain, and then calculations could be made whether it's raining or not. Those are not direct approaches, but these are we are using sensors to calculate indirectly what is happening around in the environment as well. So again, these devices, of course, weather monitoring stations and weather monitoring devices can be used for different applications. We talked about them: farming, industrial use, even in power supply, smart cities. We talked about how these data can be communicated through the internet and communicated to databases on the cloud as well, right, where weather prediction models can be applied to the data and predictions can be made. So now you have a basic understanding of how a IoT device is made. A IoT embedded device would consist of one or more sensors and one or more actuators, or a combination of these things. It will have its own power source. That means it will have access to electricity to function. It will have its own processing power, and it will have its own networking capabilities. A IoT system is a combination of one or more IoT devices taking in data through sensors or outputting data through actuators, right? And these systems, these IoT devices or IoT system, if it is one IoT device, this IoT system would be the device itself. But if there's a set of IoT devices, this IoT systems has the capability to connect with other IoT systems or to the cloud, and through the cloud that data will be processed and can be relayed to other IoT systems to carry out their functions that would be done through the internet, thus creating Internet of Things. So that is the main point I want to relay out of this. We have come through, we had tried to understand what are IoT devices, what are the IoT applications, and now we have gone through components inside IoT devices, and now I think you have a basic understanding of, if you think, oh, there's this IoT device, what would be inside that IoT device to carry out that particular function. Now you may have an understanding of IoT system or embedded IoT device, right? End of all these lessons, our end goal would be to make an embedded prototype of IoT device, right? Before going on to that, it is necessary to understand what is IoT device and how it is made. Okay. Now from this point we can go to our next topic, introduction to IoT system creation, right? So again, in this lesson we would be trying to create an embedded system, but we should have the knowledge of what is a IoT, how to create an IoT system or how to create an IoT device itself, and to do that, what are the primary factors that we have to, or what are the primary steps that we have to do. So in this introduction to IoT system creation, we will be looking at what are the steps that is needed to create a IoT embedded device. Introduction to IoT system creation. So an IoT system is a network of physical devices, sensors, actuators, and software that are connected to the internet and can communicate with each other to perform specific tasks. IoT systems can be used to collect, analyze, and transmit data in real time, enabling remote monitoring, control, and automation of various processes and systems. So this is as we spoke before in other lectures, we know what's IoT and what IoT does, and similarly what a IoT system does using IoT devices. So this is a basic definition of a IoT system. So when we are going to design a IoT device or a IoT system, what is the steps that we have to take to design this IoT system? So that is what we are going to look at in this particular chapter. What we are trying to understand is, right, So here a particular IoT device is created. This particular IoT device is created as a solution for a problem, or to streamline or to make a process more efficient. For that, we have selected some sensors, we have selected some actuators, and so on and so forth. So we are trying to understand how that process takes place, right? So the first step would be define the problem. So when you are going to make a IoT embedded device as a prototype using Arduino or Raspberry, then selecting your sensors and so on and so forth, right? When you're going to make your project, when you're going to make your prototype, the first thing is to define the problem. Identify the problem that you want to solve using an IoT system. It could be anything from monitoring the temperature of a room to tracking locations of vehicles, right? So basically, when we talked about our IoT devices, when we talked about our applications of IoT devices, we talked about how that data which is produced from those IoT devices are used in different scenarios. So we have to identify the problem first to give a solution, right? So if you go to our IoT application example, right? If you take the first example, what would be the problem? How the IoT solution is given? The problem is that the temperature in the outside environment changes from time to time. When the sun is out, it's more hotter outside. When it is winter, it is super cold outside. When the sun goes down in the summer season, it also becomes colder than afternoon. So in the temperature inside a room or temperature inside a building would change according to this, which is uncomfortable for human beings. So we need some kind of a device to monitor the temperature, monitor the outside temperature, and monitor the temperature inside, and do the necessary adjustments like changing the speed of the fan, or changing in the temperature, or the change in the blower of the AC, or increasing the temperature of the heating systems according to the outside temperature to maintain a constant comfortable temperature throughout. So the problem is the change in temperature. The solution should be to maintain a comfortable temperature throughout the day. So after this example, we can look at our next example. The problem here, or more sort of, we are trying to streamline and make a process more efficient. The process is reporting and identifying when there's a fire inside a building, right, or in some location, right, and activating the sprinklers and calling the authorities, right. By using IoT, we try to automate as much as possible. We are trying to automate the full process so that we will be able to get on top of that particular problem, right, very quickly. So we can extinguish the quicker the reaction, better when handling a fire. That means there should be quick reaction. So streamlining the process, automating the process would ensure that attention which is needed and action which is needed to extinguish the fire will be taken properly and correctly, right? So in this scenario, we were talking about using IoT to for fire extinguishing, and we can say for safety, right? So the problem, or we were mostly trying to streamline a process. Here in itself there are several scenarios, right? Several problems, including in controlling the lights in mass scale in cities to buildings, things, smart lighting systems, right? How to handle them, how to be efficient, how to be like correctly implement that information, plus other industries that would need weather information. So in this, the set of data which has been retrieved by the IoT systems, or IoT system, or the IoT devices to monitor the weather are the same, but used in different formats or different domains for different purposes. We solving different problems. So as a IoT engineer, it is important to look at that particular feature as well, right? So for example, if you are going to make a smart lock, right? If you are not able to get a RFID scanner or a fingerprint scanner, but you are able to get a camera, so what would be the solution that you will be using? In that sense, it would be face recognition. But again, when designing, so depending on the requirements of the customer, depending on the type of problem you are going to solve, you would have to figure out, right, either to automate a process and streamline it, right, be more efficient, or to resolve a problem altogether. You should be able to figure out what kind of a IoT device that is needed. So when you figure out what kind of a IoT device that is needed, then you will be able to figure out, right, like first defining the problem, and then thinking of, if such a scenario is there, right, if such a problem is there, I can use a device which can do this, right, when network with other devices like this, so and so, right? When you say, okay, we can resolve this problem by using in device X to monitor the situation, then we can use YZ devices to give a solution very quickly. So the whole system would include XYZ IoT devices. So when defining a problem, right, and we should be, if somebody says about a problem, or if we find a problem, we should be, the number one scenario is that we should be able to imagine or think of how to engineer a IoT device to address that problem, right? So that would be the first one. So identification of the particular problem. If you go back to our situation here inside a factory, right, we have to, what is the problem? There might be unnecessary fumes, there will be people affected by unnecessary fumes, there will be extraordinary amount of heat in this factory, right, produced from machines. So if these are the problems, what are the IoT devices that we can use to keep an eye on these temperatures and fumes, right? That is what we have to understand. First, understanding the problem, then understanding what kind of IoT application to be applied on it. So choose the sensors. This would be the second one. Choose the sensors. Choose the sensors that will collect data required to solve the problem. For example, if you want to monitor the temperature of a room, you will need a temperature sensor. So because we were able to, when after identifying the particular problem, right, we have to have a way to understand when the problem occurs. So that means in this factory, let's say the temperature keeps rising, right? So first we have to understand what is the temperature inside the factory itself, right? To determine whether it is harmful or not, we have to have the readings of the factory itself. So in that scenario, we should think of a device, a IoT device which monitors temperature. The sensor that would be inside this IoT device would be a temperature sensor. You can do it both ways, which is comfortable for you. Either the best way, if you are designing a product, would be from ground up. That means when you see the problem, so to identify the problem, you would need to get some data, and that data is taken through sensors. So what are the sensors that can be used? Then we can work our way through to building a device. Or if you are going to use existing devices, you can check for devices which already have temperature sensors and apply those devices. So depending on how you reach the end, how you are going to reach for the end system, right, you can choose the method you are going to follow through. Again, if you are to build a sensor from ground up, right, if somebody comes to you and you are now a IoT engineer, right, and some company comes and says, okay, we have this factory, in this factory we use thermal power a lot, so the temperature inside the factory sometimes reach very high amounts, which is harmful for the people who are working in that factory. We need a method to measure the temperature real time inside the factory. So if needed, we can switch on the fans or open ventilation or shut off the machines to control that temperature. So what is your solution? Can you build a solution? If they ask to build a solution, you can start from the sensor itself. So anyway, it should be a thermostat or temperature monitoring device, and there are products in the market itself for temperature monitoring. Either you can use that IoT device, network it to your own IoT network, and take that approach. Or if you are to build a temperature monitoring device by yourself, you will start from the sensor, and that sensor would be a temperature sensor, right? So depending on the scenario, you have to select your sensor. If another example would be, if you are going to measure the pressure inside pipes that deliver water, right, to the entire city, right, and you want to have real-time measurements around the pressure of inside the pipes around the city, because if it gets too much pressurized, the pipes would get damaged. If it is less pressure, water will not reach to homes and necessary factories and so on and so forth. So you need to always keep an eye on the pressure at every location in let's say 100 kilometers, 200 kilometers long pipe. So the first thing, what would be, so what is the problem here? The problem here is that we need to maintain a constant pressure inside the in the piping system to to uh, to deliver water for everybody in the city. So if the problem would be, if there's high pressure there will be breakdowns, if there's low pressure there will be no water delivered. So how to stop that problem? We have to maintain the pressure, so we should have proper readings along the pipe. Choose the sensor. What would be the sensor that we will be using? So the sensor that we will be using would be pressure sensors, right? So a pressure monitoring device should be there. That means there should be a pressure sensor which can monitor the water pressure in those pipes. So after selecting the sensor, choose the actuator. Choose the actuator that will be used to respond to the data collected by the sensor. For example, if the temperature sensor detects a temperature above a certain threshold, an actuator such as a fan or an air conditioner may be used to regulate the temperature. So that would be our next step. We identified the problem, then we think of the sensors that we need to use to right, when we define the problem, we first think of the sensors which are need to identify the problem. Then after that we need to select our actuators. In this case, right, we first talked about the temperature inside the factories, right? And when the sensors detect that there are temperatures going above some level, the actuators will turn on, the relays will turn on the fans, the air conditioning systems, so on and so forth. There will be there could be warning lights, there will be warning sound in the control room, there will be displays showing the temperature in real time, showing that is high, right? So these are all actuators which will be there. If you go to our second example, which would be the pumping station where we pump water to a city, right? So there will be a control station where all the sensors along the 100-kilometer pipeline would send pressure readings to that control center through the network. So then you will see whether the pressure is constant throughout or not. If the pressure is high, there will be again a warning given, and the pumping station can shut off the motors, or a valve can be opened to release some water and bring the pressure down from the pipe. So actions like that can be automated, so that that it would be instantly carried out rather than human intervention which is going to be there. So again, we define a problem, or we define a problem, or we identify a problem, or we can say that the problem we will find a method already ongoing process. We find the problem in that already ongoing process would be time taken, human error, so automation would be much better. So the solution would be automation through using IoT. So when we define the problem, to identify the problem, we use sensors, right? When the sensors identify the problem, we have to take an automated action or a manual action depending on the system, but we have to take an action. If it is automated, right, the action is normally taken through actuators. The readings of the sensors will be displayed to the people who are controlling the situation, or the people will get to know of the problem, right? Because the sensors would identify the problem. the users will get to know through actuators such as screens, warning lights, or speakers, right? So when creating a IoT device, first you have to define a problem, and for that defined problem, after defining the problem, the solution will be provided as a IoT device or IoT system. When the problem is defined, the first function of the IoT system would be to identify the problem, whether the temperature is increasing above some threshold, whether the pressure of water is increasing above some threshold. So for that we choose our sensors, right? After choosing the sensors to relay that information which is taken from sensors to the user, plus to carry out automated tasks, we choose our actuators. So these 3 points, when creating our embedded system, is very important. If you are going to make a IoT device, that IoT device will do some task, but it should have a purpose, right? The purpose is to give a solution for some problem. So we should start from identifying and defining a problem and trying to find a IoT solution for that problem. Then after that, when we think of IoT solution, we can think of the sensors and actuators which is needed. It will come naturally. If you go here, right, if you take the smart lock, if you think of the smart lock, and if you think, okay, we need much more secure locks, either with fingerprint reading, or we can remotely control the lock, or if somebody is entering the room, the lock should be able to identify that somebody has entered the room and switch on the lights and things like that, so to authenticate that person. So all these functions, right, these are problems. How to identify, how to authenticate, how when the door is open the lights come up, right, the air conditioning goes up, things like that. How do the lock knows that this is a authorized person? If the owner of the house is somewhere else and they need to know who has entered the house, even they have permission or not, if they want to know who has entered the house, how to notify them? These are problems. For those problems, we try to give a IoT solution. The IoT solution here is a smart lock. So for that smart lock, we need sensors and actuators to create that device. So one of the things that we have to recognize in this is that these three are there. By combining these 3 points, we can create a IoT embedded device or a IoT device, right? But here we are talking about IoT system creation itself. So we have to go a step beyond devices, and we have to combine those devices together and have to think of the entire IoT or entire Internet of Things, right? So the next step would be, after selecting your sensors and actuators, which means having the ability to build a device or devices, we have to choose our platform. Choosing the platform that we'll use to collect, process and store data. This could be cloud-based platform or a local server. So, right, if you go to our diagram again, the first 3 points, right, from the first 3 points, we first understand that there's a problem, and for that solution should be IoT. When we know that it's going to be an IoT solution, it's going to be either an IoT device or IoT system. But this processing power inside each IoT device is limited to processing the raw data which is being sent by the sensor and commands needed to be processed for the actuators. If you take couple of hundred or even 1,000 IoT devices producing network together, producing data sets, we would need big data processing in large scale, or we have to understand how big data works, right? For that we need cloud technology to facilitate that much amount of data which is coming from different systems. For example, if you are going to build an IoT device for, let's say, an airport, there will be many data points that would be coming in from flights, from weather stations, right, from ground control, from ticketing systems, baggage claims, security, so on and so forth. There is a huge number of IoT systems which automated systems working around the clock at all times. So there's a huge number of data which is being produced, and that data should be stored, and data should be processed correctly under secure technologies. So in that perspective, in that case, we can use cloud computing or local servers as the baseline, as the platform for this IoT system. So for example, right, we are so either a processing unit would be here with the networking for the IoT system, or you can use the cloud, or the internal server. This cloud would represent a internal server as well as the cloud functionalities itself, right? So we know that Google, Azure, and Amazon Web Services all provide web services dedicated to IoT systems. So if you go through the facilities they provide under their cloud technologies, you will clearly see that they have dedicated features, dedicated properties just to facilitate IoT systems in their cloud environment, right? So from that point, if we are to connect these IoT devices, these sensors and actuators to a cloud, right, and we need to connect these each and every IoT device to the internet, to the cloud, as well as between each other to work in a IoT system, we would need a network. That means choosing a communication protocol. Choose the communication protocol that will be used to transmit the data from the sensors to the platform. Here the word platform is for either a internal server, a database, or the cloud services. Some common protocols include Wi-Fi and Bluetooth, Zigbee and LoRaWAN. So we talked about this. We talked about these networking systems, right? If we are to normally connect with a server system or a cloud-based platform or a local server, right, we would be using Wi-Fi, Bluetooth, or other Ethernet connectivities, right? We will be using the normal protocols that are there for communicating through the internet. But if IoT devices are to talk to each other, IoT to IoT device, right, and or IoT device to the main router, or main access point of the network, or the main access point which is connected to the cloud, we can use dedicated networking protocols for IoT such as ZigBee and LoRaWAN, Z-Wave, things like this. So one of the main things that is important is when you define a problem and when you identify the sensors and the actuators needed, when you are going to design that IoT device or IoT devices for a IoT system to provide a solution to this problem, you should then choose the communication protocol between these IoT devices inside the system plus the communication method, or there should be internet communication protocols built into your IoT system. So when designing a system itself, when designing the system itself, we have to think of the ability to communicate through the internet to servers, plus IoT devices that we are going to build have to have the ability to communicate to other IoT devices either through the internet itself using the network which is already there for Wi-Fi. Let's say there's a Wi-Fi in that building, there's a dedicated Wi-Fi for this, using such methods, or by using protocols which are dedicated to IoT devices, in this case ZigBee and LoRaWAN, Z-Wave, Sigma, things like that. Then develop the embedded system. Right here, of course, the development of the embedded system is, we are talking about this, right? The embedded system could be one IoT device or many IoT devices working together. That embedded system inside those devices would have sensors and actuators. Here we are going to talk about how these in this property, in the sixth property, we are going to talk about the development of that embedded system or giving the processing ability to those IoT devices. Develop the embedded system that will connect the sensors to the platform using chosen protocol. Right, that means when you select these sensors, when you have selected these sensors and when you have selected your actuators, so you know what your IoT system is going to do, right? You have to have the processing power for extracting the relevant data from the sensors and the sending commands to the actuators. That part have to be done in the embedded system or embedded device. This may involve programming Arduino or Raspberry boards. So you can see here in the IoT device, programming an Arduino board or a Raspberry device to control these sensors and actuators, right, would make an embedded device, or having multiple devices together working in such a way, or having multiple sensors out there and one processing unit, depending on the architecture you make, the embedded system of IoT, right? So that is what is being talked about. Our main goal to understand here, the first one is to build a IoT embedded device, right? To build a prototype of a IoT embedded device, a simple project, right? We have to start from somewhere. So we are starting here. What we are trying to understand is simple project. So when we go to our simple project, right, as you can see, I have highlighted up to number 6. These are the main 6 components which would be there in an IoT system. right? But if you are going to make a IoT project, right, first you have to define the problem and think of a IoT solution. When you are thinking about the IoT solution, you think first how to, okay, if this is the problem, I have to identify when the problem occurs. So we need the sensors. Then we know that we have to identify the actuators which need to give the output, the resulting output from the data which is collected from the sensors. These two actuators and sensors should be controlled, and those data should be processed by an embedded system, in this case number 6, Arduino and Raspberry, or any other processing system. So what we are going to concentrate more is 1, 2, 3 and 6. When 1, 2, 3 and 6 is done, we will have IoT devices. If we are going to say, okay, we would need multiple number of devices, then we will go to number 5 and find our protocols to communicate in between this device, which Raspberry or Arduino, and another Arduino device. How to exchange data, what are the protocols that we are going to use. And if we want to take some data which is there on the internet itself from other IoT devices and so on and so forth, then we will be stepping into number 4, right? I think you now understand so how it is moved. First we will define a problem, select sensors and actuators, then we select the embedded system. When we are normally trying to find these products in the market itself, right, when we are going to do our first project, this is something extra from what is here, right? If we are going to do a IoT project, right, and this is going to be your first project, or you are still you are on the beginner stage, or still you want to practice, it is better to check on the internet the compatibility between the sensor you buy, the actuator you buy, and the embedded system that you are going to use, right? To make sure that that code and necessary documentation is there to do the necessary programming of the sensors and the actuators respect to the embedded system that you are going to choose, right? Because it will make life easier for you. Because if right, we are going to approach this from a beginner's level, right? One of the things that you should be looking at from the back end is these sensors and actuators which I am going to use is compatible with, let's say you have Arduino board, is compatible with Arduino. If you have Raspberry Pi, okay, is it compatible, or how can I make this compatible? Do I need what are the connections that I need, or do I need others third party chips or anything to turn these analog signals to digital signals to analog, and so on and so forth, right? These things are important, right? It would be heavily beneficial if you check if there are other projects being done through either in YouTube or in GitHub or somewhere with the following sensors and the embedded system, so that you will be able to comfortably integrate the sensors, actuators and the embedded system, because that would be the first step of creating a prototype, and you will be comfortably doing that. You may have heard of Arduino development kits. There are So those Arduino development kits are normally compatible with Arduino boards, and all the information of the data sheets and programming information will be there on the will be provided on their websites as well. So that is also a good step to take when creating a IoT device as a project for beginners, right? So that less errors will occur, less amount of troubleshooting is needed, and low complexity will be there, right? So life would be easier for you as a when you start. If when you go to such a level that you will understand the device itself just by reading the data sheet itself, right? If you started making your own boards or embedded systems, right, when you go into that sort of a level, this compatibility issues, you will find a way to make it compatible, because you understand to the core and what are the signals being omitted by the sensor and how to read those sensors. But right now we are not going into such deep levels. So in that case, when you are going to design a IoT embedded device as a project, it is better to see the compatibility is there first and follow through, because that will make life easier for you to make a project. So the seventh point, so coming back to the points that we were talking about, develop the cloud application that will process and store data collected by the embedded system. This may involve using platforms such as AWS IoT or Microsoft Azure. So again, we will use the cloud platform not only to process, but after that processed data or the data which is being collected from the embedded systems can be stored and be recalled whenever necessary. So let's say somebody wants to collect data for 1 month of the atmospheric temperature, and that data should be stored somewhere. The embedded systems will not have the storage capacity for those, because you have to always remember, IoT devices are not like laptops or computers. They are much more lower in processing power and storage capabilities and memory. Okay, so for that we can use cloud platforms to store that particular data, and we can process them and take out through cloud applications. Integrate the system. So the next one would be integrate the system. Integrate the embedded system and cloud application to create a working IoT system. Yes, so these parts are there when you now we are moving from the system, IoT systems, to the point where human interaction happens, right? Taking data from the cloud, right? Develop a cloud application means, right, storing data, reading data from the cloud, processing data from the cloud, and displaying it to a user. Integrate the system, right, with the embedded system. That means all these IoT devices with the cloud, right? Test and develop the system ensures. So test the system to ensure that it is working as intended, and develop it in the targeted environment. So here we have, when creating a system, if you take applications, so application building life cycle, right, you would understand the problem, right? Plan, build, like build would be the first prototype, right? Then build a functioning version, right? Then run it through testing, right? Alpha, beta, so on and so forth, like till you give out a production. Then monitor and maintain, of course, similar to software development life cycle. This is that particular life cycle. Monitor the system and ensure that it is continues to work as intended and perform regular maintenance requirements. So if you take IoT system, if you are going to say that we are going to use this IoT system to switch on and switch off lights in the city, right, when the sun goes down or the sunlight goes down due to clouds or something like that, right, we have to make sure that the sensors are working properly, the networking is working properly, right, the systems are online all the time, the devices are online all the time, right, each and every device is communicating correctly, the data which is being produced is produced. So there is like IT, right, or ITSM, in information technology system management, right, you have your offices, you have your applications maintenance, infrastructure maintenance is also a part of IoT. But I didn't highlight these last few parts because it is this is there, of course it is there, but it is not the part of our syllabus. We are mostly concentrating on the first 6 points, and from that 6 points, 1, 2, 3 and 6 are the points that we are concentrating mostly on if we are going to build our IoT prototype device. So from that, so these are the things, right, these are the steps, or these are the points that you need to consider when designing or creating a IoT system, right. This IoT system, if you can remove the system part, you can put a IoT device part on it. These would be the same, right, but we will then more concentrate on these highlighted factors rather than the other set. These are testing, delivery, right, after delivery. So these things will be, we are not concentrating on those points. So right now we have reached 2 hours, close to 2 hours. I think we have passed 2 hours as well. We are again going to talk about IoT solutions in different sectors, right. We will talk about these as well, and little by little, I think the next lesson after examples of IT solutions, we will be looking at IoT networking, right, and slowly we will try to move towards building our embedded IoT devices after that. Okay everyone, thank you very much. See you in the next lecture.